Here are corrections for the homework assignment that was page 224, exercises 2 and 3. Question number 22 asks you to balance each equation, identify each as the type. We're going to do the type part first right now. So this first one, I have two reactants and they're both compounds, so this is a double replacement. Letter B, I have an element reacting with a compound, so that's a single replacement. Letter C, I have a hydrocarbon and oxygen, so that's a combustion. Letter D, I have a single reactant, so this is a decomposition. In letter E, I have two reactants and they're both elements, so this is a combination reaction. Letter F, I have two reactants and they're both compounds, so this is a double replacement. Letter G, I have a single reactant, so this is a decomposition. And letter H, I have two reactants. They're both compounds, so this is a double replacement. So those are the types of reactions. Now, going to the balancing part. All right, so balancing these, one lead, two nitrates, one nitrate, so I need a coefficient of 2 in front of potassium nitrate, two potassiums, one chromate, So this is balanced. Letter B, two chlorines, one chlorine, coefficient of 2 in front of potassium chloride. One potassium, two potassiums, a coefficient of 2 in front of potassium iodide. Two iodide, this is balanced. Letter C, 3 carbon, 1 carbon, a coefficient of 3 in front of carbon dioxide. 6 hydrogen, 2 hydrogen, a coefficient of 3 in front of water. So I have 6 plus 3 makes 9 oxygens. So again, this is where I'm going to use that little trick. I'm going to put my number I need because it's odd over 2. And then I'm going to come through and I am going to, double my coefficients. So I didn't have a coefficient in front, so now it becomes a 2. 9 over 2 is going to become 9. 3 is going to become 6. And 3 is going to become 6. I think I'm balanced. I'm going to check. 2 times 3 makes 6 carbons, and I have 6 carbons. 2 times 6 makes 12 hydrogen. 6 times 2 makes 12 hydrogen. 9 times 2 makes 18 oxygen. 6 times 2 is 12 oxygen, plus 6 more makes 18, so this is balanced. All right, 1 aluminum, 2 aluminums. We need a coefficient of 2 in front of aluminum hydroxide. 3 hydroxides. Okay, well, we're going to have to count them as oxygens and hydrogens, so we'll kind of erase that. All right, so let's look at hydrogen next because it's only in one spot. So I have 3 hydrogens. I have 2, actually I don't have 3 hydrogens. I have 6 hydrogens. So I need a coefficient of 3 in front of water. Oxygen-wise, I have 3 times 2 makes 6 oxygens here. I have 3 plus 3 more here makes 6 total. So this is properly balanced. All right, lithium, 2 lithiums, we need a coefficient of 2 in front of lithium. 2 oxygens, 1 oxygen, we need a coefficient of 2 in front of lithium oxide, which means we need to change our coefficient in front of lithium to a 4. And this is properly balanced. Letter F. Again, this is a double replacement hydrogen and iron swapped partners. So I have 1 hydrogen and 2 hydrogens, so I need a coefficient of 3 in front of hydrogen chloride. I have 3 chlorines, I have 3 chlorines. I have 2 irons, I have 1 iron, so I need a coefficient of 2 in front of iron, which now means that I have 6 chlorines. So I'm going to need to change this coefficient to a 6, which means I need a coefficient of 3 on my water. So I have 3 oxygens, and I have 3 oxygens. I think I'm balanced, but I'm going to check. 6 hydrogens, 3 times 2, 6 hydrogens. 6 chlorines, 2 times 3, 6 chlorines. 2 irons, 2 irons. 3 oxygen, 3 oxygen. This is properly balanced. Letter G. 1 magnesium, 1 magnesium. 1 carbon, 1 carbon. 3 oxygen, 2 and 1 more makes 3 oxygens. This is a skeleton equation that is also a balanced equation. Letter H, this double replacement reaction, 1 barium, 1 barium, 2 cyanides, 1 cyanide, so I need a coefficient of 2 in front of hydrogen cyanide. 2 hydrogens, 2 hydrogens, 1 sulfate, 1 sulfate. This is properly balanced. 23 says complete and balance an equation for each reaction. To do that, I have to identify these as to type first. So I'm going to do types again. I have in letter A 2 compounds that are both reactants. 2 reactants that are compounds, so this is a double replacement. In letter B, I have 2 elements reacting, so that's going to be a combination. Letter C, I have an element reacting with a compound, so that's going to be single replacement. In letter D, I have this hydrocarbon, so this is a combustion. I have a single reactant, so this is a decomposition. And letter F is also a decomposition. So working to our balancing, now again remember we said that this first one was a double replacement. So that means we're going to have swapping of partners. So remember our definition of double replacement is positive ions, okay, exchange. So calcium is a metal and is positively charged, and mercury is a metal and is positively charged. So my products are going to be Ca, all ionic compounds, so +2, NO3, -1, need parentheses, and my other product is going to be Hg. And again here I'm going to know that Hg has a +2 charge because this is -1 and there are 2 of them. So that means this mercury over here had to be +2, which means my mercury here has to be +2. And I have iodine with a -1, so I need HgI2. Now I'm ready to balance. 1 calcium, 1 calcium, 2 iodines, 2 iodines, 1 mercury, 1 mercury, 2 nitrates, 2 nitrates. This happens to be a skeleton equation that is also a balanced equation. Letter B, we said that this was a combination because we had 2 reactants that are both elements. So my only possible product, because this is a metal and a non-metal, is aluminum chloride. And that's an ionic compound, so my symbol is Al. Its charge is +3, Cl -1, charge of -1, so I crisscross down, and that's the lowest whole number ratio. Now I'm ready to balance this. 1 aluminum, 2 chlorines, and 3 chlorines, so I have to make them both 6. I need a coefficient of 3 in front of chlorine, and a coefficient of 2 in front of aluminum chloride, which means I need a coefficient of 2 in front of aluminum, and this is now properly balanced. Letter C, we said, was a single replacement reaction. We knew it was a single replacement because we had an element reacting with a compound. Because it's single replacement, that means that we have to check our activity series of metals. And for this reaction to take place, silver has to be higher on the activity series than hydrogen. And unfortunately, it is not. So what we're going to write for this one is no reaction. Okay, so there are no products because, again, silver is not higher than hydrogen on the activity series of metals. Letter D, this was a combustion reaction. We knew it was combustion because we have a hydrocarbon and oxygen. The products of all combustion reactions are CO2 plus H2O. Balancing this, 2 carbons, 1 carbon, so we need a coefficient of 2 in front of carbon dioxide. 2 hydrogens, 2 hydrogens. So we have 2 times 2 is 4 oxygen here, plus 1 more makes 5. So that's an odd number. So I'm going to do the little 5 over 2. And then I'm going to come through and multiply all my coefficients. So I didn't have a coefficient in front of C2H2, so it just becomes a coefficient of 2 because 1 times 2 is 2. 5 halves is going to become 5. My 2 is going to become a 4. And my coefficient in front of water that was nothing, which is 1, is going to become a 2. So I think I'm balanced. I'm going to check. 2 times 2 is 4 hydrogens or carbons, and I have 4 carbons. 2 times 2 is also 4 hydrogens. 2 times 2, I have 4 hydrogens. I have 10 oxygens here. 4 times 2 is 8, plus 2 is 9, 10. This is properly balanced. Our next reaction, we said, was a decomposition because we have a single element. The only thing this can decompose into is its elements. So we're going to have our products be Mg and chlorine. Now, I do need to remember that chlorine is diatomic, so it has to be Cl2. And when I come to balance this, 1 magnesium, 2 chlorines, 2 chlorines. This is a skeleton equation that is also a balanced equation. Lastly, we have a decomposition reaction. Now, this is not a fair one. Okay, so this is not one that would ever be on like a test or quiz. Not that you're taking any, but it wouldn't ever be on there. Because when peroxide decomposes, it actually decomposes into water and oxygen gas. So when I balance this, I have 2 hydrogens, 2 hydrogens, 2 oxygens, and I have 2, 3. So 2 isn't going to work. So I'm going to try a coefficient of 2 in front of peroxide. So now I need a coefficient of 2 in front of water. And I have 2 times 2 is 4 oxygen. I have 2 plus 2 more is 4 oxygen. So this is properly balanced. So that's your homework from page 224, questions 22 and 23, going over that. Have a good day.